The source of a powerful cosmic ray. Did the late heavy bombardment actually happen? Did Titan create Saturn's rings? And in Space Bites Plus, we might be able to intercept Comet 3I Atlas. All this and more in this week's Space Bites. Cosmic rays are one of the major concerns for astronauts when they fly into deep space away from the Earth's protective magnetosphere. You've got mostly protons, single atoms of hydrogen, but you can have other atomic nuclei all the way up to iron that are just flying through space at relativistic speeds, close to the speed of light. And when they crash into your body, they can break apart your DNA and they can cause increased risk of radiation downstream. And trying to understand just how many cosmic rays there are out there, what are the energy levels, this is an ongoing field of research for astronomers. And they have detectors for cosmic rays down here on the surface of the Earth. They can detect when a cosmic ray hits the atmosphere, collides with particles in the atmosphere, and then breaks apart into this cascade of smaller particles that then rain down over this larger area. And then based on the particles that rain down, astronomers are able to calculate what was the energy of the particle that hit. The most energetic cosmic ray ever detected was called the Oh My God particle. It was detected back in 1991. But the second most powerful was detected a lot more recently, and it's called the Amaterasu particle, which is named after the Japanese sun goddess. Had about 40 million times the energy of the particles that are smashed together in the Large Hadron Collider. If you want a specific number, it is 240 exa-electron volts. This particle entering the Earth's atmosphere was detected by an international collaboration called the International Telescope Array Project. And so the question you might have is, what caused it? Well, astronomers still don't know what is the source of these extremely energetic cosmic rays. Of course, the standard laundry list of suspects is always sort of thought of. You have black holes, supermassive black holes, supernova, hypernova, gamma ray bursts, the accretion disks around black holes. You have pulsars, magnetars. You've got a lot of objects that are capable of accelerating particles to very high levels, but no smoking gun has been pinned down yet. Astronomers looked at the source of the Amaterasu particle, and they were able to at least figure out, did it come from deep space or did it come from a galaxy? And they were able to pin down that it appears to have originated near M82, also known as the Cigar Galaxy. And this is a galaxy that has high levels of star formation in it. So it could be that this particle originated at this galaxy, which is 12 million light years away, and was able to make it all the way to Earth, enter our atmosphere, and sort of surprise everybody at the energy levels involved. Now, if you want to go into more information, we've got a story about this from Matt Williams on Universe Today. If you look at objects in the solar system like the Moon and Mercury, they have been pounded by asteroids over the long history of the solar system. And astronomers are able to calculate the age of when those impacts happened just by tracking the craters, measuring the sort of this crater, and then this crater has a bunch of smaller craters inside of it, and that crater has a bunch of smaller craters inside of that. And so when you look at the far side of the moon and you track the number of craters on the far side of the moon, you get a rough age of about 3.9 billion years ago when most of those craters were formed. And so there was a time early on in the solar system when there was a lot of asteroids smashing into objects like the moon, like Mercury, probably Earth, Mars, and so on. And this is known as the late heavy bombardment. But there's been a bit of a mystery because this is about 600, 700 million years after the formation of the solar system. And this is not what you would expect. You would expect that you would have this flurry of impacts happening early on in the solar system, and then it would slowly die down in this very smooth curve. So why did you get this flurry of activity at that time? Well, the common answer is that it was the influence of the gravity of Jupiter, that during that period, Jupiter was migrating or interacting with the asteroid belt, caused a bunch of asteroids to be flung around at a time when things had already sort of settled down, and some of these would have crashed into the moon and Mercury and so on. the Chinese Space Agency sent a sample return mission to the far side of the moon, this place where you see all of these craters presumably formed at this same time during the late heavy bombardment. It brought back samples from this region called the South Pole Aitken Basin, and it found that the region was formed in a giant collision about 4.25 billion years ago. In other words, about 350 million years earlier than the late heavy bombardment. So one really intriguing possibility is that there is no such thing as the late heavy bombardment, that it didn't actually happen, that there was actually a lot of even bigger asteroid collisions that were happening earlier on in the history of the solar system. It's just that then later on, a fairly large impact hit the moon, blasted out a bunch of debris, and it all rained down at roughly the same time that obscured the earlier bombardments that were happening. And to calculate the age of when this impact happened, they used a technique called radioisotope dating. Now, you're probably familiar with carbon dating, where you were looking at the ratios of carbon-14 and other isotopes of carbon to figure out how old a piece of wood is. But you can use that same technique looking at ratios of lead in rocks to figure out when those rocks were formed. And so you had this impact on the moon, it melted big chunks of the moon, and that set the start time for when you would get uranium decaying into different isotopes of lead. And so it's entirely possible that the impacts on the moon started much, much earlier. So there was like an early heavy bombardment as well as a late heavy bombardment. And we've got a story about this from Andy Thomaswick. And if it feels like there's a lot of information in my brain about this, that's because I just did an interview with Dr. Craig Walton. He had gone around the world, collected samples of meteorites, and found a similar story. And it sort of nicely lines up to what the Chinese are discovering as well. That interview is coming out next week. And so make sure you subscribe, and then you'll get a notification of when that interview is live. Titan is one of the most fascinating worlds in the solar system. It is the second largest moon. It has a thick atmosphere, nitrogen rich. It has water ice on its surface that is so hard it is kind of like rock. It rains methane. It has seas of liquid methane. This is a really cool world. But it also is kind of a bully in the Saturn system. And astronomers think that perhaps Titan is the cause of Saturn's rings. To kind of trace back this story of Titan's influence on other moons in the Saturnian system, astronomers looked at the orbit of this other moon called Hyperion. Hyperion is relatively small compared to Saturn, but it is large enough that it should have gone through hydrostatic equilibrium to form into a sphere. And yet it is misshapen, has a very bizarre shape to it. And so according to models, astronomers calculated that one possible explanation for the strange shape of Hyperion and the presence of Saturn's rings is that there was a larger proto-Hyperion earlier on in Saturn's history. About 400 million years ago, it got too close to Titan, was torn apart. Part of the debris reformed into Hyperion and gave it this irregular shape. And the rest of the material was either consumed by other moons in the system or went into rings around Saturn. And so if that's true, then it would mean that Saturn's rings are relatively young and not as old as the solar system itself. And in fact, there are other moons in the Saturnian system that appear to have sort of similar strange irregularities with their orbits and maybe even their composition. And so it could be that Titan has been bullying the rest of the moons in Saturn's system for billions of years. We've got a story about this from Evan Goff. Astronomers have recently noticed a star that had been shining at its regular brightness and then dimmed down to about 3% of its regular brightness for about 200 days. And there are lots of explanations for why stars can dim. You've got some planet transiting in front of the star. You've got just various periodic oscillations in the brightness of the star. It's expanding, it's contracting. But in this case, this is a brown dwarf star, and it just dimmed this significant amount. And now astronomers have worked out that it was probably due to a gigantic ring system. And so when you think about Saturn, right, you think about the rings as this sort of disk around the planet. And so imagine you've got a brown dwarf, you've got this disk around this brown dwarf, and it's at a bit of an angle. And so for about 200 days, we were seeing the star through the disk of the rings, which was making it a lot dimmer. And then the orientation of the rings from our perspective change, and then we could see the star again, and it will probably dim again in the future once it continues its orbit. To call this a ring system, like, this is next level. It's probably about 0.17 astronomical units. That's about half the distance from the sun to Mercury. And this is orbiting around like a brown dwarf or maybe a super Jupiter. And so the thought is that this is the result of some kind of planetary collision, that there was once planets orbiting around this brown dwarf, and then they smashed together and turned into this debris field that was so opaque that it caused the star to dim from our perspective. I've got a story about this from Mark Thompson. Another day, another example of complex organic molecules being found out in deep space. And this time, we're going to talk about a molecule called glycine. And this has been found in many examples, both in space as well as in samples returned from spacecraft. For example, OSIRIS-REx brought back samples of asteroid Bennu, and in that were this molecule glycine. How do you get these organic molecules forming both in deep space and in these icy objects, comets, asteroids, things like that? The traditional idea is that you needed some kind of liquid water, that there was some point where Bennu was close enough to the sun, there was enough radiation coming from the sun, maybe the pressures inside were high enough that you would get liquid water forming. And then when you had liquid water, then you would have this solvent that would allow organic molecules to be able to combine and recombine into these more complicated things. You know, glycine, but you get amino acids and other organic molecules. But that has never felt really satisfying, especially when we see these molecules in comets, things that maybe have never been close to the sun. And so researchers have done a series of lab experiments where they wondered if there was another pathway where you could get these chemicals like glycine forming. And they found that it doesn't require liquid water, that instead, if you just blast ice with radiation, you can get a similar outcome, that you can have chemistry happen in these objects just out in deep space, in the outer solar system, purely from the radiation coming from the sun. And so this might explain how you can get this chemistry happening, is that it's not just requiring liquid water, that it can just happen in ice as long as there's enough radiation. And there's plenty of radiation out in space. I've got a story about this from Matt Williams. Every week we do a vote on our channel where you tell us what you thought was the best space news story of the week. And the winner last week was that SpaceX is changing its mind and now it's going to build a city on the moon. So thank you everybody who voted. Now we're going to put this week's vote into the post tab here on our channel. So you can go right now and vote. If you're not seeing the votes show up regularly here on the channel. But if you want to encourage it, then go to a bunch of previous polls and vote, vote, vote. So last week I told you that you would see a really cool animation if you liked this video. And in fact, when I said like, then something should have happened on your screen. But you know, some of you didn't see it. So maybe you just like didn't believe. Maybe you just didn't trust in the algorithm enough. So once again, trust in the algorithm, press the like button on this video, and you should, I guarantee, see something really cool. Unless YouTube messes it up, which, you know, come on. The exoplanetary system HR8799 is one of my favorites. And I'm like, sure, you're saying, yeah, Fraser, come on. Like a jumble of numbers and letters, that is your favorite exoplanetary system. Well, take a look. Look at this video of this exoplanetary system. We are seeing it face on. We are watching the planets orbit around the star. This is not an artist's illustration. This is not an animation. This is actual images of the star and its planets. The light from the star has been blocked by a coronagraph, and so you're actually watching more than a decade's observations of these planets orbiting around. You can count them. You can see them. Like, I know you probably think I'm hyping this, but I actually did a talk in front of an audience and put this system up, and just we all gazed slack-jawed at these planets going around this star. This thing is crazy. I want more of these. And this is a very special system. It's only about 130 light years away from us. And the smallest planet is about 5 times the mass of Jupiter, while the biggest one is about 10 times the mass of Jupiter. But there is a bit of a question, like, are these really planets, Or are they brown dwarfs or something that is like more star-like going around this other star? And if they are, then I am no longer interested. I am only interested if this was an actual exoplanetary system. But good news, astronomers have used James Webb and they have detected the presence of hydrogen sulfide in the atmosphere of at least one of these planets. Hydrogen sulfide, that is the rotten egg smell. And sulfur is really important because you can get carbon and oxygen forming in more complex molecules in a purely gaseous brown dwarf formation process. But to get sulfur, you needed some kind of solid material. In other words, that at one point in the ancient history of this star system, there were planetesimals, chunks that had solid sulfur on their surfaces. Those merged together and joined up with these larger gas giants. And eventually you got the planets that we see today. And we can prove that they are planets because they were part of a planetary formation process because of the sulfur that's in their atmospheres. So it remains on my list of the best exoplanetary systems out there. I've got a story about this from Mark Thompson. Ganymede is the largest moon in the solar system. It is so big that it has an intrinsic planet-wide magnetosphere. I know it's not a planet, planet-wide, worldwide, entire, complete magnetosphere. And, you know, we don't see very many of these. Earth has one, Jupiter has one, but Mars doesn't, Venus doesn't, Mercury doesn't. And so if you have a magnetosphere, then that gives you the potential for auroras, where you have particles from the sun interact with the atmosphere of the planet or world, and you get these cool lights in the sky. So does Ganymede have auroras? Well, it doesn't have a very thick atmosphere, but it does seem to have auroras. Now, NASA's Juno spacecraft did a flyby of Ganymede back in 2021. It was able to use its ultraviolet instrument to observe Ganymede as it flew past. The way the instrument is designed, it can only see in these sort of separate strips. But even in those strips, it was able to detect these chains of patches, which are known as beads. And we see the exact same kind of structure in the auroras on both Earth and Jupiter. So it appears that if you like stood on the surface of Ganymede, you would, with the right kind of very sensitive eyes, you might be able to see auroras in the sky during high solar activity. One of the most famous red giants in the sky is called Mira. And Mira is actually a binary system of two stars, and one of them is dying. And it is very similar to the kind of star that our sun is. When the sun runs out of hydrogen in its core, it will switch to burning helium. That'll cause it to blow up, turn into this red giant, and then it will puff out its outer layers off into space. And then it will go through this process where it sort of increases in size, decreases in size. This will last about 1 billion years. And as it goes through this process, it will just lose more and more mass until finally all that's left is just the core of the star. And that's how you get a white dwarf. And so in the case of Mira, we are actually watching it go through this process of shedding material. And so astronomers have tracked down 2 blobs of gas that were released from Mira in recent times. One of these happened about 50 years ago. The other happened about 200 years ago. The larger one contained about 7 times the mass of the Earth and just this blob of material that is drifting away from Mira. And Mira is kind of cool because it is moving through the interstellar medium. It is constantly shedding all of this material, and the interstellar medium is buffeting it, and it has given it a comet-like tail that is following it through space. You sort of see it behaving like a comet as it's moving through the Milky Way. But this just gives us a really great insight into what the future of a star like our sun might be as it's going through that process of running out of fuel and starting to throw out its outer atmosphere into space. This is kind of what it's going to look like. Got a story about this from Carolyn Collins Peterson. Have you already forgotten about asteroid 2024 YR4? Well, I will not let you forget it, because this is the asteroid that astronomers thought might crash into the Earth in 2032. And now that has been ruled out, but there's still a chance that it's going to hit the moon in 2032. But will it? Well, you need to take more observations of its movement. And so the best tool for the job is the James Webb Space Telescope. And at the time that you're watching this, astronomers will have used it to collect data on the movements of YR4. And then they're going to do it again in February 26th. And from those observations, they will be able to track with much better accuracy what the future holds for this asteroid. And we will either get it's gone back down to 0, or we will have a much more accurate understanding of whether or not it's going to hit the moon, which I really want it to. So let's just stay tuned. I'll let you know the results once they're in. A couple of weeks ago, we were hoping to see the launch of the Artemis II mission, which is going to carry 4 astronauts around the moon for the first time in 50 years. Unfortunately, during the wet dress rehearsal, they were tanking the hydrogen into the Space Launch System, and they discovered some leaks that had them stop the test a little bit early and then push the launch back to the next window, which is unfortunately several weeks later. And so this week on Thursday, NASA did another wet dress rehearsal where they tried to tank the spacecraft to find out if the leaks were resolved. They went through the tanking operations, and they were very carefully watching the concentrations of the hydrogen and making sure that they weren't getting leaks from the system. And they think it went well. We had a more elaborate confirmation from NASA that came out about the time that we're releasing this video. So, there may be more information coming. But at this point, we continue on to the countdown for launching to the moon. So on February 20th, the astronauts are going to enter quarantine. Hopefully that'll mean that they won't get sick before they get onto their spacecraft and fly around the moon, and they're away from the Earth for a week. And this is one of those things that you think about, right? That can you imagine if you got sick, had COVID or something while you were flying on this mission? You would be sick, you'd have reduced capability. And so this quarantine stage is something that NASA has done for all of their space missions for a long time. And this gives them a 14-day window for when they can launch, which is now expected to happen sometime in early March. So good news, I guess. Hopefully we will see that rocket take off now in just a couple of weeks. I hope you're enjoying this episode of Space Bites. Now keep in mind that we create these videos, we release them here on YouTube, and YouTube puts ads in it. We are not allowed to turn them off. Ads at the beginning, ads at the end. We're able to turn off the ads in the middle, but the rest of the ads, we can't stop it. And so we think there's a much better experience over on Patreon. We post all of our videos on Patreon completely for free. We don't put it behind any kind of paywall. You don't have to donate. You can just watch it. And to encourage you to do that, we put one more story into Space Bites over on the Patreon version. And this week's story is pretty cool. I think you're going to want to see it. And that is that a team of engineers have proposed a mission to catch up with interstellar object 3I Atlas. So I'll put a link in the show notes. You can go watch that version of this exact same episode of Space Bites. And then remember, they're all over there for free with no ads over on Patreon. And of course, this is just a fraction of all of the news stories that we're covering on Universe Today. We typically do 30 to 40 stories by a big team of writers, and we can only get through just a handful here in Space Bites. So if you want to see all of the stories, go check out the Universe Today website, subscribe to the RSS feed. But if you want it all just like boiled down for you, I write a weekly email newsletter that goes out every Friday, and I just provide a summary of every single story that we're covering on Universe Today. I write every word, it's completely free, and there's no ads in it as well. So go to universetoday.com/newsletter to sign up. One of the viewers is concerned about how much money is being made by creators and how we're compensated, and why is YouTube taking so much money? And I will respond to that. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Andrea Pedretti, Bear Lake Roofing, Brian Bodie, Carradwin, Chuck Hawkins, Commander Bailock, Cy Nielsen, Dark Finger, David Gilton, David Matz, Evan Pro, Greg Feely, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Smith, Michael Purcell, Nordspace, OneStepForAnimals.org, Paul Buck, Rankaidu, Richard Williams, Sean Sargent, Stephen Fowler-Munley, Team 49, Telescopes Canada, Wolfgang Klotz, and Zeldabor Galactic Defender, who support us at the Master of the Universe level, and all our patrons. All your support means universe to us. I got this on the YouTube comments that came from Fucky You. Doesn't YouTube already pay you if you get enough subscribers or likes or whatever the heck to your channel? How much money is enough? I mean, come on, dude. I pay for YouTube Premium, yet I still get sponsor ads from you creators now. And on top of that, I'm getting space taken up on the stupid thing with videos that I can't even watch because apparently their members only are some crap. And I'm like, dude, I already pay somebody every month. They're violating my contract, and you are too. Thank you for your concern. So I need to sort of break this down to a bunch of pieces. So the things that you're talking about here, as a YouTube Premium subscriber, you don't get any ads on watching YouTube videos. You don't get them at the beginning, you don't get them in the middle, you don't get them at the end. I'm a YouTube Premium subscriber. I highly recommend it. But you're exactly right that some YouTubers will try to make some more money from their work. And so they will do sponsorships inside their videos. And like, to be fair, YouTube pays you very little money. Not enough to pay for your time, not enough to pay for your editors, not enough to pay for really anything. That for most YouTubers, the only way that they can actually make a living wage from doing this is to get these sponsorship contracts from some outside agency. That's why you see the regular ads that I'm sure you're all familiar with. Now, we don't do them because we're supported by the patrons. And so the patrons support us over on Patreon. And that means that we don't have to go and get any other outside advertising. We are able to turn off all the ads inside our videos. I know it's not an issue for you, but it's an issue for other people. And we don't have to do any of those sponsorship ads. Now, we do thank the patrons, but that's sort of the price. That's the deal. The other thing you're talking about is these memberships. And this is another service that YouTube will provide where you can allow your fans to join your channel membership and then release videos only to the members, and they get to watch them first, or you never make them available to the wider audience. Now, we don't do that on our channel and never will. We've been asked many times by YouTube, and I don't like it. Instead, we use Patreon. And what's different about us than from this sort of membership system is that we release most of our content completely free on Patreon without any ads. And so if you just subscribe to us over on Patreon for free, you would get all our videos. There would be no memberships, and there would be no sponsorship messages, and there'd be no ads, even though you have YouTube Premium, which is cool. And it's a much better experience for most people who can't even afford YouTube Premium. Obviously, we're in this age where the various platforms, I mean, not just YouTube, think about what's happening with Facebook and Instagram and TikTok and all of them. They are trying to get as much revenue as they can from their audiences. They're trying to figure out every single way to monetize them. Like, I gotta be honest, YouTube is the best. Of all of the platforms, the one that treats its creators the best, and I think its audience, is YouTube. But obviously, that is always in balance, and that they're trying to figure out new ways to make money, and things could go south in the future. Like, I'm just waiting for the day when YouTube tells us that we can't turn off the mid-roll ads, and that we're going to be forced to put mid-roll ads into our videos. It feels like that's going to happen any day now, but maybe not. Who knows? So yeah, I understand where you're coming from. We try to minimize it as much as we can. Other creators, they don't have as many options as we do, and if they didn't put those ads in, they just wouldn't make videos at all because they wouldn't be able to afford it. So, I mean, if you like our content and you kind of share our philosophy, then come over on Patreon and follow us for free. Again, no money is required. You can just watch them. And hopefully that's a better viewing experience for you. And this is exactly what we've been complaining about week after week. All right, we'll see you next time.